Hello students. One variation of the transportation problem which we have seen in my earlier video is transshipment problem. In the book it is available on to page 268. So if you can just read this, it is as an intermediate node. It can be also termed as warehouses where the exchange of goods takes place. And usually it is there just to facilitate the logistical arrangements, maybe between two cities or maybe between two countries. You know, so basically the original question will get transformed into uh, such arrangement. You can see here. See, the original question, original problem had the origin and destination directly, but now we have these two intermediate locations, warehouses, which are also called as transshipment nodes, like Kansas City and Louisville. And first, the material will come from the original plants to these warehouses, and then from here it will be sent to the retailers or the retail outlets. So this is a typical arrangement, but in even it can be given as in a table format, and if it is a table format, it will look like this. It will be two tables, and from plant to warehouse. So Kansas City and Louisville are the warehouses, and then from warehouses to retail outlets. This table and this table gives the cost per unit of the transportation, right? So as usual, we have to first declare the variables, and we can say the variables can be, this is your x13 here, which we have seen earlier. Same logic we are going to use. Then this will be x14 here, transported from Denver to Louisville. This can be x23, right? Like this. So first we will declare the variables. Here it can be, say for example, here this will be x36, right? Because we have different numbers given to all the uh, destinations as well as origins, we can use them. So this is going to be the first declaration of variables, will be the first thing, and then you will clearly write down. The only difference is at this warehouses, your logic will be whatever material which is coming in has to go out of these warehouses. So the input will become equal to the output, right? So you will, in addition, your uh, objective function will be to minimize the total cost of transportation, which will be given by 2x13, 3x14, and so on, and you add all those cost elements, and you will try to minimize it. So your final model will look like this. This is going to be your final model. So minimize all the cost elements together becomes total cost. So minimize the total cost of transportation. Then these are your original nodes which we will use less than equal to sign. These are your destination nodes which equals to use equals to sign, which as I explained in the transportation video why we have to use equal to sign. And these are the transshipment nodes because we have two transshipment nodes. Basically you can write this whatever incoming and whatever is outgoing equal to, or you can take it on one side and write equal to 0. So basically here for this particular Kansas, x13 plus x23 equal to x35, x36, x37, x38. So you can write it like this, or take the other one side variables or terms to the other side, and then you will write one side equal to 0 like this. So you will, here you are seeing the minus minus. So once you set up this into your Excel solver, and obviously the last one is all the variables should be non-negative. So once you set up this in Excel solver and solve the problem, you will get the answers like this. This will be your answer for your transshipment problem. Thank you.